This video is about base multiplications as they are used in Vedic math. This is video number 4, part 1 of 3. I'm splitting this video in 3 sections. This is the first part, the basic part, which deals with the base multiplications and derives the formula. We'll go over a brief outline here. In this section, we would try to compare with the conventional math a base multiplication with conventional math. We'll do a multiplication in conventional math and also using the Vedic math. Let's talk about here some special multiplications. There are some special multiplications in conventional math also, like 37 times 100, 53 times 10, like 79 times 1, and these are special and student doesn't have to work on these multiplications, can get the answers right away. And answers are 53 times 10 is 530, add a 0 to the right. 37 times 100, add 2 zeros to the right, 3700. 79 times 1 is 79. Multiplication by 1 does not change the result. It gets same result as the number being multiplied is. In the Vedic math, we can do all that and many more, like we can do 37 times 99 in addition to 37 times 100. We can do 98 times 99 in a special way. 53 times 85, like 63 times 99, 37 times 9, and many more. 89 times 999. Okay, let's do base multiplications as they are done in Vedic math. In these multiplications, at least one operand is close to a base number, and we prefer natural base number. Sometimes we use proportional base numbers also. Okay, let's take an example. We're going to take example of 998 times 817, and you know the drill. On the conventional math, we take rightmost digit of the multiplier, multiply that with 998, the multiplicand, write the answer. This is intermediate product. The next intermediate product is take the one next digit of the multiplier, multiply with 998, and we write 998 shifted to the left by 1. Then we do the next digit 8, multiply that with same multiplicand here, get 7984, and shift that again by one more place to the left. So we have 3 intermediate products. Then we add them all together to get an answer of 815366. So we did 998 times 817. We start multiplying 9898 with the digits in the multiplier in each of these intermediate products on separate lines, and shifted the second line shifted by 1 to the left and third line shifted by 2 to the right, and then add them together to get 815366. Let's do the Vedic math way. In Vedic math way, where I did two numbers just like we did before, 998, 817 on two different rows. Okay, now we look at base numbers here. 998 is very close to a base number of 1000, and that's the base we are going to use. So we write on base how we write the base. Base number is 1000, and we write down on the above these numbers we are trying to multiply. Okay, next we are going to compute deviations. Deviations of the two numbers we have from the base number 1000. So let's see how we define deviation. So deviation 1, I'm going to say 998 minus 1000 is minus 002. So it's the number minus the base is my deviation. Negative number sign I'm going to use for operation here. So I'm going to use to subtract two numbers. 002 has 3 digits, 1000 has 3 zeros to the right, and we try to keep it 3 digits in the deviations. Okay, so minus the next deviation I compute from 817 minus 1000. Next number minus base is minus 183. Okay. So we get a minus 183 here. Then next we do is ready to multiply now. Okay, we multiply in two parts, left and right. Okay. On left we apply crosswise. What do we apply? We apply the operation minus on the two numbers 817 and 002. So we do 817 minus 002. 817 we apply crosswise. 817 minus 002 is 815. Mathematically correct term would be add the deviation 1 to the number second number. That would be 817 plus minus 002. And some people, the confusion would come in, hey, are we subtracting? I just say use the apply crosswise here, which is we're going to apply 8, do the crosswise here, 817, then negatives minus, and then 002. So we apply operator minus subtraction between on two numbers 817 and 002. You could get same 815 by 998 minus 183, but I find 817 minus 002 a lot easier to do, so I use 817 minus 002. So on the right we multiply vertically, minus 002 times minus 183. Okay, so right multiply vertically, minus 002 minus 183 is negative signs cancels out, 366. Okay, so we have a on left 815 and on right 366. Number of digits on the right 3, number on the right is positive, and we can say that answer is 815 366. But another way to do is to say that answer is left times the base plus the right. Okay, so we can say left times base plus right, which is 815 times 1000 plus 366, 815 366. Sometimes this detail would come in handy when the number of digits on the right is not equal to number of zeros in the base, or uh, right part. All right, you can do some exercises now, like 996 times 995, 97 times 98, 997 times 998, and some more. To next section now. Next section, we're going to talk about examples of various cases. We just did one case here where both of the operands were less than the chosen base number. So we'll do some more examples here. Let's see what's and apply the same formulas. So example 1 is 1003 times 1002, where both numbers are more than the base number. Let's choose the base number first. So base number is 1000. 1003 is more than 1000, and so is 1002. Okay. Okay, now we are going to compute deviation. Deviation 1 is plus 003. 1003 minus 1000 is 003 and is positive, so we use positive, and then 3 zeros here on the base. We try to use 3 digits on the deviation. That kind of gives me a hint that I do need 3 digits in the right part. Okay. Deviation 2 now is 002, and okay, and now let's look at left part. Left part is cross apply. We apply 1002 plus 003, or 1003 plus 002, which is 1005. So we 1005 goes on the left, and right multiply on the right. We multiply vertically. 003 times 002 is, with plus signs, is 006, and we need 3 zeros here, we need 3 digits here. Students would generally have issue here, would forget number of digits required on the right side. So that's one of the errors here. situation where the students mess up every now and then. Okay, so it's a practice, practice, and practice. Review the slide and practice. Let's go do another example here. So answer is 1005006 here. Okay? 1005006. When number of digits on the right is equal to number of zeros in the base and right part is positive, we don't have to do base times the left part plus the right part. We can just say two numbers together. Left is 1005, right is 006, and the answer is 1005006. Okay, let's do another example. Example 2 here. In this case, we will have 1243 times 98. 1243 times 98. 98 is very close to base number of 100, and 1243 is way off. So we choose a base number of 100. We are choosing base number 100 so that this is the number that's close to 98. And now we start to compute deviations here. Deviation 1 is 1243 minus 100. It is plus 1143. It's plus. 1243 is more than minus 100. So 1143. Deviation 2 is 98 minus 100 is minus 02. Okay. All right. Now let's see what to do on left. On left, we do this crosswise apply. 1243 minus 00 minus 02. We apply minus on the two operands 1243 and 02. You could do same thing on the right. 98 plus 1143 are apply plus on the two operands 98 and 1143. You get a 1241 either way. Okay, on the right we multiply vertically. It's a minus 2286 plus 1143 and a minus 02 multiplied together, we get a minus 2286. So on the left we had example of both numbers were more than the base number, the plus in deviations. On the right we have a case of first number is more than the deviation of 100 and second number is less than the base number and was negative and a positive. Okay? And the answer in this case I better do base times. So minus 2286 go on the right. This is a negative number and it doesn't have a two digits, the required two digits. So we would do a 1241 times base and minus 2286. So we do left times 100 plus right, and which is 1241 times. Let's look at steps used in the multiplication, base multiplication. First, we find a base. Second, find deviations, which is a subtract operation. Then determine left by cross applying, which is add or subtract. Okay, then determine the right by vertically multiplying. This is the only multiply we do, and deviations are usually small, and this multiplication is easy. Okay. And for proportional base, apply that proportionality to left. So if we had a base of 2 times natural base, then we would say 2 times of the left. Then match number of zeros of number of digits on right to number of zeros in the base. Either pad with zeros or carry some digits to the left. Then answer is left right. After we match the number of digits on right, answer is left right. That's it. That's all, folks. Okay, let's do some exercises now. You can do 98 times 89, 1003 times 1015. So here the deviations were both negative, and here the deviations are both positive. So with 1003 times 990, a positive deviation for the first operand, and second operand it's a negative deviation, and some more. And 578 times 998, and 995 times 986, and some more. Okay, let's do some more examples. This time we will use base of 10. Last time we used larger bases. So numbers we are trying to multiply 17 by 13, and base we decided to use 10. So base is 10. Let's find deviations now. First deviation plus 7. Next deviation plus 3. 17 minus 10 is plus 7, and 13 minus 10 is plus 3. Now on the left, we're going to cross apply either 17 plus 3, which is 20, or 13 plus 7, which is also 20. So we use 13 plus 7 here, 13 plus 7 is 20. And the right, we would do a vertically multiply 7 and a 3. Plus 7 times plus 3 is 21. So 7 times 3 is 21. Okay. And answer is left times base plus 21 is 221. So 17 times 13 is 221. Okay, let's do another way. Also right is 21. The two digits, we only need one. This 2 need to be carried to the left. Okay. So we would carry this 2 to the left, and that would make it a left become 20 plus 2, which is 22. Answer is now 22 from the left and 1 from right. 22, 221. Answer is 221. Okay, let's do another example here. This time we will do 12 times 18, and base we are going to use 10. Okay, deviations now. First deviation, 12 minus 10 is 2. Next deviation, 18 minus 10 is plus 8. Now we will do a left, which is cross applying. So we did 18 plus 2 is 20, and similarly 12 plus here plus 8 is also 20. So we got 20 on left. On the right, we would do a vertically multiply plus 2 times plus 8 by 16. Okay. Now answer is again left times base 20 plus 16, 216, and also 16 has two digits. Number of zeros on the base is 1. We only need one digit on the right. So this one get carried to the left. So when you carry 20 plus left becomes 20 plus 1, 21. And the answer is 216. 21 from left and 6 from right. 216. Okay. We use base of 10 to extend multiplication table. So we try to, if you knew only tables until 10 by 10, we can extend that using the base of 10 we just did. We found out 17 times 13 and also 12 times 18, and you can do 11 times 15 and 13 times 19, etc. Let's go next section here. Next section is we would develop this method we just used. We'll prove that the method we use has a basis. Okay, let's do up the method we just used. Recall that deviation is number minus base. So to compute deviation, we say we subtracted base number from the given number. Number is, from that number must be base plus deviation. We need two operands. One is multiplicand and other is multiplicand. Let's continue the method. Let n1 be the multiplicand. We decided we need two operands. One is multiplicand. We use n1, the first operand, as multiplicand, and 2, the second operand, the multiplier. Then x is the base. That's the variable x in algebra. That's x be the base. Okay. And then a1 is n1 minus x. We say deviation 1 is number minus the base, deviation 1. a2 is the division 2 is n2 minus x is division 2, which is number minus base. Okay? That means n1 is from here is equal to x plus a1 and n2 is x plus a2. From this equation here, n1 is x plus a1 and n2 from this equation is x plus a2. All right, let's continue with the development. We know that we had already established that n1 is x plus a1 and n2 is x plus a2, and we need to multiply the two numbers. So we do n1 times n2. n1 is x plus a1, so x plus a1 times n2 is x plus a2, x plus a2. So we have n1 times n2 is x plus a1 times x plus a2, okay, and which is equal to x squared plus x times a1 plus a2 and plus the constant term a1 a2. You can use a vertical and cross multiply to of x plus a1 times x plus a2 to arrive at x squared plus x times a1 plus a2 and plus the constant term a1 a2, and which is equal to, we just factor out x from the first two terms here. But from first term we got other factor is x, from the next term the other factor is a1 plus a2 and plus the constant term. Okay, let's go regroup this thing. If you combine x and a1 like x plus a1, this is n1. So we have x times n1 plus a2, okay, and the constant term, okay, that's x plus a1, that's x times n1 plus a2, and this is our left term we computed. Apply crosswise the deviation. So n1 was first operand, n2 was the second deviation. So we apply second deviation n1 plus a2, and that's what okay, and that's this is left thing we have been doing so far. Okay, again, if we regroup it, so combine a2 with x, so and x a1 here, so x plus a2 is n2, n2 plus a1 here, okay, and the constant term here, okay, and so x times n2 plus a1 or plus a1 a2, the constant term. Okay, so all right, let's continue. We already know that n1 times n2 is equal to x times n1 plus a2 plus the constant term we just established on the previous slide, and also is equal to x times n2 plus a1 plus the constant term a1 a2, okay, and which is x times left plus right, and that's what we have been using, and then we just derive the formula we just have been using. Okay, all right, let's take example here. Example is n1 is 1015 and n2 is 1003, and let's compute deviations now. Base is 1000, a1 is first deviation 015, second deviation a2 is plus 003, and left is n1 plus a2. N1 is 1015 and a2 is 3. 1015 plus 003 is 1018. Okay, and right is a1 times a2 is 015 is times 003 is 045. Okay, number of digits in the right is 3, number of zeros in the base are 3, so we can say answer is 1018045, left followed by the right, 1018045, and you can also do the extra step we have been doing. Okay, extra step is answer is left times base plus the right part, 1018 times 1000 plus 45, it is again 1018045. Okay, there's some references here, and our teacher's manual is my main reference. Tirthaji uses this method in chapter 1, and Glover's book, Vandana's book, and Bhatia's book, they all have sections on base multiplications. Okay?